Hello everyone, my name is Dr. Bush, the chemistry instructor at the Peak Construct for Higher Learning, aka the Peak Tutors. Today we'll be talking about significant figures. In chemistry, significant figures are the digits of values which carry meaning towards resolution of the measurement. But then, the definition of significant figures I love most is the second one. The term significant figures refer to the number of important single digits, 0 through 9 inclusive. That's telling us that what? 0 is also a significant figure, depending the type of 0, of which we are going to talk about today. So the term significant figures refers to the number of important single digits, 0 through 9 inclusive, in the coefficient of an expression in scientific notation. By scientific notation, we simply mean standard form. Now, what are the figures that are significant? Of course, you should know that all non-zero digits are significant. What do I mean by non-zero digits? By non-zero digits, I mean 1, 2, 3, 4, 5, 6, 7, 8, 9. The figures on the board here, they are what? They are all significant figures, anytime, any day. But then, where we have problem is when it comes to what? 0. Because zeros may or may not be significant. Zeros is divided, or zeros, they are divided into what? Into 3, depending whether it is significant or not. We have 3 kinds of what? Zeros. We have what we call the leading zeros. We also have what we call the captive zeros. And we also have what we call the trailing zeros. We are going to look at each of these one after the other. Let's take leading zeros. Now, what are leading zeros? Leading zeros are zeros that are what? That are located at the terminal left of a digit. I mean, they are zeros that come before the first non-zero digit in a figure. For instance, if I have 0.0000419. Now, these zeros that I have here, they are the leading zeros. They come before the first non-zero digit. And my first non-zero digit here is what? Is 4. So in this case, I have what? Just 3 significant figures here. If I express this in scientific notation, I'm going to have 4.19 exponential what? Minus 1, 2, 3, 4, 5. Exponential minus 5. So here I have what? Just 3 significant figures. So any 0 that come before the what? The first non-zero digit in a number, that 0 is said to be what? A leading 0. And hence, you should know that what? Leading zeros are not significant. They are not significant. So that means if I have 0.05, the 2 zeros here, they are what? They are leading zeros. Hence, they are not significant. So which means I have what? Just 1 significant figure here. That is for what? For leading zeros. How about captive zeros? Now, captive zeros are zeros that are located in between 2 non-zero digits. They are in between what? Figures that are what? That are significant. Now, you should know that what? Captive zeros are significant. They are significant. Now, how do I know if they are significant? Imagine I have a figure like this, 2001. Now, 2001, the 2 zeros I have here in between 2 and 1, which are non-zero digits, the 2 zeros I have here, they are captive zeros. Now, these zeros are what? Are significant. That tells us that what? 2001 is what? Is 4 significant figures. So also, if I have figures like, let's say 30.04. 30.04. The 2 zeros I have here, they are what? They are captive zeros. They are held in between what? 2 non-zero digits. Hence, they are significant. That means what? I have what? 4 significant figures here. That is that. Now, how about trailing zeros? Trailing zeros is where we have a little complication. We are going to talk about that now. Now, you should know that trailing zeros may or may not be significant depending on the form it comes. Now, if I have 300 as written in this form, and if I have 300 dots, trailing zeros are zeros that are what? At the terminal right of a digit. They are zeros that end a figure. Now, they may or may not be significant, like I've said before. If I have 300 as written in this form and I have 300 dots, like a decimal point in this form, this 300 in this form, I have just one significant figure. But 300 as written in this form, I have what? 3 significant figures. Now, how do you simply know about this logic? Trailing zeros that come before or after decimal points are significant. But if there is no decimal point after or before the trailing zero, it is not significant. Which means if I have 85,000 as written in this form, I have just 2 significant figures. But if I have 85,000 dots, it becomes 5 significant figures. How about if I have 85,000.00? Now, these whole zeros here, they are trailing zeros because some come before the decimal point and some come before the what? After the decimal point, they are said to be what? Significant. So hence I have what? 7 significant figures here. So trailing zeros may or may not be significant depending on the form it comes. If I have 10, here I have just what? 1 significant figure. But if I have 10 dots, it becomes what? 2 significant figures. How about if I express some of these figures in scientific notation? That's, by scientific notation, I mean standard form. If I have 900, I have 9.0 exponential 2, and I have 9.00 exponential 2. 900 as written in this form is just 1 significant figure. But 9.0 exponential 2 as written in this form, I have what? 2 significant figures, because this is a trailing zero that comes after what? A decimal point. A decimal point is very important for a zero to be what? To be significant. But then just for trailing zeros, leading zeros in whichever form, they are not significant. 9.00 times 10 raised to the power 2 as written in this form, I have it to what? 3 significant figures. So we have gone through the 3 types of zeros we have. We have leading zeros which are not significant. They are zeros that come before the first non-zero digits. And then we have what? Captive zeros which are placed in between what? 2 non-zero digits. Captive zeros are significant. And we have trailing zeros which come after the end of what? They are after the terminal right of a digit. They may or may not be significant, and which we have gone through them. If they don't have decimal points at the end or maybe in between them, they are not significant. But if they do have decimal points maybe before or after them, it becomes they become what? Significant. Now we are going to be talking about rounding up and rounding off. Rounding up and rounding off. I would like you to subscribe to this YouTube channel, so we can always enjoy ourselves. Now, rounding up and and rounding off. There is a distinct distinction between rounding up and rounding off. You should know they have difference. When do we round up and when do we round off? You're going to round up a figure when that figure is 5 or above 5. You are going to round up. Rounding up means you are going to add 1 to the preceding figure. That's the number that precedes the figure you want to drop. So by rounding that figure up, it means you are going to add 1. If I have a figure like 30.436 and I want to round this figure to 4 significant figures, or let's say 2 decimal places, still the same thing in this case. Now, if I want to round this figure to 4 significant figures, my figure to be rounded is is 6. Now, 6 is above 5. Once the figure is 5 or above 5, you are going to round it up. And by rounding up, it means I'm going to add 1 to the preceding figure here. That is 3. So to 4 significant figures, my answer becomes 30.44. That is to 4 significant figures. That is rounding up. How about rounding off? We are going to round off a digit. By rounding off now, I mean we are not going to add 1. You are just going to drop the value to be rounded. By rounding off, we are not simply going to add 1 like I said. Now you are just going to drop it. And what are the figures to be rounded off? Now we are going to round off figures that are 5 or below 5. that are 5 or what, or below 5. Imagine I have something like 30.44, and I want to round this figure to what? To 3 significant figures. Now, to 3 significant figures, this is my figure to be dropped. 4 here is to be dropped, and you can see it is what? It is less than 5. So which means I'm not going to add 1 to what? To the preceding figure, which is also 4 here in this case. So which means to 3 significant figure, I have what? 30.4 to 3 significant figures. That is what? Rounding up and rounding off in simple terms. But there is a case where we have what? Anomalies. Now, imagine we want to round 5. If you check my definition of rounding up and rounding off, I say you can round up a figure when the figure is 5 or above 5. And you can round off a figure when the figure is 5 or below 5 or less than 5. Which means, what are the cases, or in which case can we round up 5, and in what case can we also round off 5? 5 has a problem. So I will target the 5 problem. But then in the real sense, we can call it the odd even rule. So let's talk about the 5 problem quickly. The 5 problem. The 5 problem. The 5 problem here indicates when do we know how to round up 5, and when do we know when to round off 5. If 5 is followed by non-zero digits, if I have 30.44531 and I'm asked to round this figure to 4 significant figures, rounding up or rounding off 5, there are 2 things you have to consider. You have to consider the figures after the 5 and the figures before the 5, or the figure after the 5 and the figure before the 5. Now, first thing you should consider is the figure after the 5. Is it a non-zero digit, or are there non-zero digits after the 5, or it is just 5, or 5 followed by only zeros? These are the 3 cases we are going to be talking about. When 5 is followed by what? Non-zero digits, when 5 is followed by just zeros, or when it is just 5. Remember, I told you that you are going to first consider the figure after the 5. If there are non-zero digits after the 5, we are just going to round up 5, which means to 4 significant figures, this is going to be equivalent to what? 30.45 to 4 significant figures, which means I consider the fact that there are non-zero digits after the 5. What if there are no non-zero digits after the 5? In that case, I now begin to wonder, should I round up my 5 or I should round off the 5? 30.445 as written in this form. I want to round this figure to 4 significant figures. Remember, I told you, when you want to round up or round off 5, you have to first check if there are non-zero digits. In this case, there are non-zero digits. That is why I rounded up my 5. But in this case, there are no digits at all. Now, which means I checked the figures after the 5, nothing. You now have to consider the figure before the 5. If that figure or if that number is an even number, you are going to round it off. By rounding off now, I mean you are not going to add 1 to the preceding figure. But if that figure is an odd number, you are going to round it up. What do I mean? If I am to round, or if I were to round this figure towards to 4 significant figures now, I'm going to have 30.44. Reason being that there are no non-zero digits after the 5, and I have to consider the figure before the 5. Is it an even number or or an odd number? Because this is an even number, the rule stipulates that we are going to round it off, meaning we are not going to add 1. This rule also applies if 5 is followed by just zeros. Please underline the word just zeros. If I have 30.44500 and I want to round this figure to to 4 significant figures, 5 is just followed by zeros, not non-zero digits as it were here, 3 and 1. But here I have 0, 0. just zeros. The rule that applies here will also what apply here, because there are no figures here, and here I have what just zeros. Now I have to check the number or the figure before the 5 that precedes 5. This figure is an even number, 4, which means what? I am going to round it off. By that, I will not add 1. I will just drop the 5. So which means I have what? 30.44 to what? To 4 significant figures. But if I have an even number, if I have 30.435 and I have 30.43500, if I want to round this figure towards to 4 significant figure, what do I have to consider? Are there numbers after the 5? There are no figures after the 5. It's just there. Now check the figure before the 5. The figure before the 5 is an odd number. The rule states that we are going to what? Round up. By rounding up, I mean we are going to what? Add 1 to the preceding figure. So to 4 significant figure, this number here becomes 30.44 to 4 significant figures. I believe we are following. And then same rule that applies here will also what? Will also apply here, because 5 is just followed by what? By zeros. Which means that what? If I want to round this figure becomes what? 30.44 to what? To 4 significant figures. That is that about what? About rounding up and rounding off. Please don't forget to subscribe as we all enjoy this session of Chemistry Made Easy. We're still talking about what? Significant figures, and then now we've talked about what? Rounding up and rounding off. Now the last thing we're going to talk about in this session is the addition and subtraction rule in an arithmetic operation. Let's talk about arithmetic operations. There are certain rules we must consider when carrying out mathematical operations. We have the rule that guides addition and subtraction, and we also have the rule that guides multiplication and division. Now let's pick what? Addition and subtraction. Let's talk about the rule that guides what? Addition and subtraction. It's going to be very easy. It's actually is very easy. I'm really sure you're enjoying yourself. Like I said, don't forget to subscribe. Now let's pick addition and subtraction. What is the rule that guides what? Addition and subtraction in any arithmetic operation? The rule here states that when you add or you subtract in any arithmetic operation, we are going to leave our answer to the smallest or the least number of decimal place. Please underline the word decimal place. We are going to leave our final answer to the what? To the least or the smallest number of what? Of decimal place that is occurring in the arithmetic operation. What do I mean by this? If I have 30.42 plus 15.5 minus 19.359. Here I have 30.42. 30.42, I have what? 2 decimal places here. 15.5, I have what? 1 decimal place. And then 19.359, I have what? 3 decimal places here. By the time I punch this on my calculator, I will make sure, following also the rules of rounding up and rounding off, that applies here. Now I'll make sure I leave my answer to the smallest number of decimal place that is occurring in the arithmetic operation. I have 2 decimal places here, I have 1 decimal place here, and I have 3 decimal places in this figure. Now the list of these 3 that is occurring in this operation is what? Is 1 decimal place. So my final answer must be to what? To 1 decimal place. Like I said, underline the word decimal place for addition and subtraction. They follow the same rule. If we punch this on the calculator, I have 30.42 plus 15.5 minus 19.359. By my calculator, I have 26.561 as the whole figures the calculator gave to me, but I'm going to leave my answer to what? To one decimal place, which means my final answer is going to be what now? 26.6 to what? To one decimal place. So if we add, or when we add or subtract in any arithmetic operation, we are going to leave our final answer to the smallest or the what? Or the least number of decimal place occurring in the what? Arithmetic operation. It's not a must, it should be what? One decimal place. There are cases where the least number of decimal place in the operation can be 2 decimal places, or it can also be what? 3 decimal places. So just check which is the least number of what? Of decimal places in the arithmetic operation given to you. So you are going to leave your answer to what? To the smallest or the least number of what? Decimal place. But when it comes to multiplication and division rule, the rule for multiplication and division, multiplication and division. If I have 16.53 multiplied by 1.2596 divided by 14.21. The rule for multiplication and division here states that what? We are going to leave our answer to the least or the smallest number of significant figure. Please underline the word significant figure for multiplication and division. Significant figure. We are going to leave our answer to the smallest or the least number of significant figure occurring in the arithmetic operation. 16.53 has 4 significant figures. 1.2569 has what? 5 significant figures. 14.21 has what? 4 significant figures. Now, in this case, I'm going to leave my answer to the smallest number of significant figure occurring in the operation. Here in this arithmetic operation, the smallest here is what? Is 4. So my final answer will be to what? To 4 significant figures. So if we punch this on our calculator, we are going to have 16.53 multiplied by 1.2596 divide by what? 14.21. By my calculator, I have 1.46524,898. So if I want to express this in the proper number of what? Of significant figure, I'm to leave my answer here to what? To 4 significant figures. And this will be what? 1.465 to what? To 4 significant figures. If I were to use this same example, assuming I've erased 1, now which means what? The least number of significant figure in this arithmetic operation is what? 3 significant figures. So which means I'm going to leave my answer to what now? To 3 significant figures. 16.53 has what? 4 significant figures. 1.2596 has 5 significant figures, and then 14.2 has what? 3 significant figures, which means my final answer is going to be to what? To 3 significant figures. So if I do same thing, if I punch this on my calculator, 16.53 multiplied by 1.2596 divided by 14.2. By my calculator, I have 1.466280845. So I'm going to leave my answer to what now? To 3 significant figures, and that becomes what? 1.47. Correct, or what? To 3 significant figures. So we have talked about what? Significant figures today, And under this, we talked about rounding up and rounding off, and also talked about what? The rule that guides what? Addition and subtraction, and also multiplication and what? And division. So for today, we have come to the end of this episode of Chemistry Made Easy. I remain my humble self, Dr. Bush, from the PEAK Construct for Higher Learning, aka the PEAK Tutors. Please do not forget to subscribe and like this video. Thank you very much.